Welcome, everyone. So today I'm going to talk about the GraalVM project. More specifically, I'm going to talk about GraalVM in the context of Kotlin. Before we begin, a quick disclaimer. I'm not working on GraalVM. Everything that I'm going to show you is my own experience, and opinions are my own. This talk is not going to be some technical deep dive into how GraalVM works, but I'm going to show you concrete examples, how you can use GraalVM with Kotlin. Has anyone heard GraalVM before? OK, a couple of hands. So what is GraalVM exactly? If you take a look at the documentation, it says GraalVM is a universal virtual machine for running applications written, well, in a lot of languages. It's an open source project hosted on GitHub, Oracle/Graal. And if you take a look at the repo, there are lots of components of Graal. For example, there is a virtual machine. Also, there is a compiler. There is a component called truffle. So let's take a look at each of these components. If you download the GraalVM distribution from the website, basically you are downloading OpenJDK 8. But it comes with an extension called the JVM compiler interface. And this was a JDK enhancement proposal. The goal of this proposal was to separate the compiler from the VM. So now compiler engineers can write dynamic Java compilers in Java. Sounds like a lot of fun. And one of these Java-written compilers is called Graal. Graal should be a high-performance JIT compiler for the JVM. I'm going to show you examples how fast Graal really is. And it is basically replaces the C2 server compiler in a regular hotspot. And it's not just for Java. It also supports scripting languages. So why is this important, or why is this interesting? Some of the scripting languages has very high performance runtime environments. For example, if you are using JavaScript, you can use the V8 runtime, which is really efficient. But some other scripting languages doesn't come with, for example, a JIT compiler. With Graal, if, for example, you would run Ruby, you would run your existing Ruby application on top of Graal, you can achieve 4x or 5x performance improvement. And to be able to support scripting languages, GraalVM uses a component called the truffle framework. It's a language implementation framework. And what you can do with truffle, basically, you can take some programming language, and you can write an interpreter for that language. And by doing that, basically, you can convert that programming language into a Java-based abstract syntax tree. And you can run this AST on top of the JVM. It sounds like a little bit crazy, but it actually works. And you can achieve Java-like performance for scripting languages. By the way, truffle is written in Java, so you can take a look at the source code, or you can even modify it. You can write implementations for your favorite languages. Truffle, out of the box, comes with support for Python, Ruby, R, and JavaScript. So you can use these languages right now. Another language support module of Graal is called Sulong. Instead of targeting the dynamic languages, it supports static languages like C or C++. Basically, this is an LLVM bytecode interpreter, and it is also written in Java. So all these components together is what you can think of as a polyglot platform. You can use your bytecode-based programming languages, you can use scripting languages, or you can use static languages and run these languages on the same VM. And you cannot just run these languages, you can also interoperate between the languages. So traditionally, if you want to interoperate between different technologies, usually you have to run your applications in different processes, and to exchange data between the processes, you have to use some kind of serialization. For example, you can use HTTP REST over JSON or XML or something. Instead of Graal, you can interoperate on the VM level. So basically, you can create an object in one programming language, and you can pass this object into some other programming language. And this interop has basically no overhead. So for example, you can do things like you can call into the R language from Kotlin. If you are doing statistical computing, or you have to draw charts or plots, it might make sense. Or if you have a Node.js application written in JavaScript, and you want to reuse some implementation, some business logic written in Kotlin, you can actually call Kotlin methods from JavaScript. Or you can even use NPM packages from Ruby if you would like to. So this is truly a unified virtual machine, and it comes with some benefits. For example, if the JVM, for example, gets a better garbage collector, now you can benefit from this change in all the languages Graal supports. Or if the compiler is getting smarter, basically you can also benefit from this change. And GraalVM comes with support for native execution, which means ahead of time compilation. It has a special purpose virtual machine called Substrate. And what you can do with this technology is you can take your bytecode and all your other resources, and you can bundle them together with Substrate, and you can create native executables. If you are doing this, you are not depending on the Java hotspot anymore. So you can take this executable, copy it to some other machine, and without installing anything, you can just use and run your executable. This was a very brief introduction to Graal. Now I would like to show you two examples. My first example is how you can run Kotlin faster, and the other example is how you can run Kotlin without the JVM. Basically, my first example is going to be a benchmark of the Graal compiler. If you Google for Kotlin plus benchmark, you will quickly bump into this repo. It is maintained by JetBrains, and this repo should be benchmark the Kotlin language features and the Kotlin standard library. Most of the benchmarks are highly specialized. So, for example, they are measuring companion objects or lambdas or loops. So I try to find some benchmark that's rather generic. And one of these benchmarks is the Euler benchmark. These are basically implementations for some of the Euler problems. If you are not familiar with these problems, these are mathematical and computer programming problems. For example, the problem number 2 is to find the even Fibonacci numbers. It comes with Kotlin and Java implementation. And if you take a look at the source code, you will quickly notice a comment in the header. It says, all tests here work slower than Java. Interesting. So I wanted to know what is the overhead of using Kotlin in this specific benchmark. A quick side note, if you think your application is running slow because you are using Kotlin, I have some very bad news. This is a synthetic benchmark. We are basically running the same function over 1 million times, so it's not a real-world application. But we will see what overhead Kotlin has. So these were my benchmarks, running the Java and Kotlin implementation without Graal, and we are going to compare it running on top of Graal. I have measured the average time per operation, which means the lower values are actually better. I did a couple of warm-ups and a couple of normal iterations, and I have established a baseline. These bars are normalized values, so this is the baseline Java performance. And if we are comparing it with Kotlin, you can see that Kotlin is indeed has some overhead across all the benchmarks. On my machine, this was 25%. And let's see what happens if we are using the Graal compiler. As you can see, Java is still faster, but the difference between the two benchmarks is much smaller. Also, a few of the benchmarks, GraalVM beats the Java implementation. So this is nice. And if we are comparing the Kotlin implementation with and without Graal, you can see that the Graal compiler can save you some CPU cycles. Please note that I haven't touched the implementation. I didn't change the source code. I'm only running the same benchmark with a different JVM and benefiting some performance gain. Again, this is a synthetic benchmark. If you want to benchmark your applications at home, I have a couple of tips. Keep in mind that Graal is just a Java program. It runs inside the same JVM as your application does. So there is a bootstrapping phase. This means basically when the JVM loads all the class files of the Graal compiler itself, and it takes a little bit of time to warm up the compiler. Also, the Graal compiler is allocating memory on the JVM heap. If we are using some profilers, you will see a slightly increased heap usage, but this doesn't mean that your whole application is going to use more memory. It just means that the Graal compiler is allocating memory on the JVM heap. For example, versus the C2 compiler, it's allocating memory on the native heap, so the memory will be used either way, but keep in mind that Graal uses the JVM heap. All in all, if you are benchmarking Graal, you should pay attention to let your application warm up and always try to measure the peak performance of your app. Okay, so the second example is how you can run Kotlin without the JVM. In this example, I'm going to use the Substrate VM with the Graal compiler. And a few things about Substrate. It has some very nice properties. For example, you have access to almost all of the Java platform APIs. You can use packages like IO or non-blocking IO or the time package, streams package, really almost all of the platform APIs. Substrate also supports Java features like threads. So, for example, you can use RxJava with Substrate. I have tried it, it works. The garbage collector in Substrate understands things like weak references, and you can even use reflection. So basically, you can use any JSON library like Jackson or JSON. As any technology, it also has limitations. The most important limitation of the Substrate VM is dynamic less loading, because we are ahead of time compiling the whole application. The compiler needs to know all the classifiers that you are going to use, so you can't dynamically load classifiers at runtime. This is important. For my example, I'm going to use HTTP4K. Is anyone using or have heard about? Okay. This is actually a very nice framework. Its philosophy is server as a function. And instead of using things like annotations or reflection or compiler plugins, it actually only uses Kotlin language features, which makes it the perfect candidate for ahead-of-time compilation. I'm going to show you some code. This is my build script. And as you can see, besides the Kotlin standard library, I'm only using 2 dependencies. And these are all the jar files that I'm depending on. So it's a small application. This is my whole implementation, a single main function. And I have a function called app. It maps a request to a response. I'm extracting a query param called name and reply with a greeting and the local time. It's basically a time server. So to be able to compile a native executable, first you have to build your project. Here I'm using Graal with the shadow plugin. If you are not familiar with this shadow plugin, this is about basically to package your whole application into a single jar file. Sometimes it's called the Uber jar or fat jar. This is the same concept. So what I can do is to pass this fat jar to my native image command. It comes with the GraalVM distribution. It performs the actual ahead-of-time compilation, and we can verify that we have the native executable. What I would like to point out that my whole application packaged together with the Substrate VM, it only takes less than 7 megabytes. So it's fairly small. We can also verify that we are only using system shared libraries. So on my macOS, I'm depending on Core Foundation and libz, basically, that's all. Of course, we can run the application. And just to verify that it works and doesn't crash at runtime, we can start to send requests. It works, it's all there. But what is much more interesting is when you are measuring the runtime memory usage. Here I'm comparing the native executable with my Java version running on the JVM, and I think the numbers are speaking for themselves. That's a 40x reduction in runtime memory usage. Is anyone using Docker or some container runtime? Okay. You're going to love this. Since the second release candidate of the GraalVM, the native image has a special flag called static. And as its name implies, if you turn this flag on, your native executable won't depend on any dynamic dependencies. So what you can do with this flag is to write Docker files like this. So you can start from scratch. You don't have to use any base image. You don't have to install the JDK. You can just put your native executable into an empty container. And this is my image. It's less than 9 megabytes. It starts up in a couple of milliseconds and uses basically less than 10 megabytes of RAM. So this is really nice. So should you go home and AOT compile all your existing applications? Probably not. Please keep in mind that if you are running server applications that running for a very long time and uses very large heaps, this is basically what the JVM is optimized for. So using Substrate might make sense if you want to, for example, write command line tools or something when the startup time and low memory usage is really important. Or if you are targeting the cloud, investing into some function as a service solution, these kind of Docker images can really make a difference. And now you may ask, can I or should I use Graal in production? Is this some research project or tech preview or production ready? Well, it's release candidate 2, but if you have used our hashtag and tweeted about this event, you have basically used GraalVM already. Twitter is using GraalVM in production today. Also, if you are not interested in the ahead-of-time compilation or the language interop features, you just want to use the Graal compiler. It's already packaged in OpenJDK 9 and 10 if you download the latest binaries. They are hidden behind a few VM flags, so you have to use unlock experimental VM options and some other stuff. But the JVM CI interface and the Graal compiler is already in OpenJDK. And if you want to learn more, I highly recommend the official documentation. I would start with the yGraal document. It's really nice. You can also start to follow people on Twitter. They are very active. You can always be up to date with the latest news. And if you go home, download Graal, have any questions or run into any issues, please talk to me. And if you have any questions right now, please use one of the microphones.
Hi, so you said that the Substrate VM is useful for like command line applications. Do you know if it's possible to make desktop applications without the JVM with it, like with the JavaFX?
Okay, so if you are meaning JavaFX, it should work, but it's not working right now. There is an issue in GitHub, so they are aware. There is no technical limitations, but right now, because of the limitations of the Substrate VM, it's not working. But I think it will at some point in the future.
Thanks.
Have you tried to compare Graal compiler compile time with standard Java compiler, the compile times?
I think it's kind of difficult to measure the compile. So keep in mind that this is a JIT compiler. This doesn't compile your source code into bytecode. It converts your bytecode into native code. It's a JIT compiler. So you can actually measure the times that it takes to do the compilation, but I haven't tried. It's supposed to be fast. It's a JIT compiler.
Hey, could you share some guidance on how do you think all this relates to the cross-platform capabilities of Kotlin that we've explored previously? Are they orthogonal to each other, or what was the relation between the two from your perspective?
I think it's orthogonal, yes. So Kotlin native focuses on bringing Kotlin to any possible platforms. And this is kind of the other way around, where GraalVM tries to pull all the languages into a single runtime. So they have very different use cases.
Great, thanks.
Hi, did you run the benchmarks on the Substrate VM as well, or the Kotlin benchmarks?
No, I haven't tried.
Okay.
Right now it's documented. Substrate is slightly slower than the Java hotspot, but they promise that they will resolve this issue. So at some point in the future, they will be in the same league.
Thanks.
Do you have some examples where you interoperate with, I don't know, Python or Ruby?
Yes, actually, I wanted to do a SIR demo, but I didn't have the time. So, I mean, I didn't have the time to prepare all the things for the demo. I'm interrupting between Node.js and Kotlin. I'm actually using, for example, Exposed, the ORM library for Kotlin. So I have written all my business logic in Kotlin and created just the front end in Node.js. And I can create instances of my Kotlin objects. I can call methods on these objects, and I can use my data classes to exchange data between the two runtimes.
Thank you.
I can show you the demo on my machine later. Okay, so no more questions. Thank you.